R-Shield Geofoam, the trusted lightweight fill material. The perfect solution for solving structural fill challenges.
The fjords and mountains on the west coast of Norway are famous for their beauty. In many places, the mountains fall more than 1,000 meters, almost vertically into the fjord. Road building in this area is, of course, difficult and expensive. The landscape in Norway varies widely. Soft and compressible subsoil is another challenge to the road engineer. The road called Strømsveien near Oslo had for years caused trouble with large and uneven settlements. The subsoil was very weak, consisting of peat overlying soft clay to a depth of 20 meters. Reconstruction of the road required the road profile to be raised and at the same time the overburden pressure on the subgrade to be lowered. The latter in order to get the settlements under control. Construction started in 1972. The excavated material was mainly taken from the old road pavement. During construction, a concrete layer was encountered in the subbase. Knowing that this was a surface layer, which was once at the same level as the bridge decks, it could be concluded that the road had settled almost 2 meters during the last 30 years. An exceptionally lightweight material was needed for the construction of the road. The Norwegian Road Research Laboratory had for some years had good experience with insulating boards of plastic foam for frost protection, and it was decided to put in a 1-meter layer of this material. A new road pavement was designed to be placed on top of the plastic foam. The plastic foam used was expanded polystyrene. It was delivered in blocks of 3 meters length with a volume of 1.5 cubic meters. The weight of each block was only 40 kilograms and could easily be handled by one man. The blocks were placed directly on the formation without any protection. The direction of the blocks was across the road, and they were laid from the center line outwards. If necessary, the blocks were cut using a chainsaw. To get the prescribed height of polystyrene, the blocks were placed in 2 layers of 0.5 meters. And to obtain a good connection between the 2 layers, timber fasteners were used. The construction was successful, and several plastic foam fills with increasing heights were built in the following years. In 1980, a new stretch of the E18 was constructed around Askim in Østfold. This included a 4-meter high fill on both sides of a pedestrian underpass. The subsoil was soft clay under a desiccated clay crust of 3 meters. The difficult subsoil conditions made it favorable to build the fill with plastic foam to obtain the required factor of safety against sliding. Uneven settlements were also predicted between the tunnel and the embankment if ordinary soil fill was used. The side slope of the blocks can be varied, but should not be steeper than 2 to 1. Expanded polystyrene is soft when regarded as a subgrade material, and special care should be taken in the design of the road pavement. Nearly all plastic foam fills are protected by a 10 to 15 centimetre thick reinforced lean concrete slab. Both theoretical analyses and bearing capacity measurements show that the concrete slab gives a significant and sufficient increase in the bearing capacity. The common procedure is to install the reinforcement mats in the middle of the slab and then pour the concrete. On this site, the contractor chose to pour the concrete in 2 layers and place the reinforcement in between. At the same time, the slab will protect the polystyrene from petrol and other chemicals which can dissolve the polystyrene foam. A conventional road pavement is constructed on top of the concrete slab. Gravel and well-graded sand are commonly used as sub-base material. The base course consisted of penetrated macadam. The aggregate was placed using self-propelled machinery. Afterwards, the aggregate was compacted and finally penetrated with bitumen. To finish the reconstruction work, 2 asphalt surfacing layers with a 10 centimetre total thickness were placed. The first plastic foam fill was built in 1972. We are now coming back to the site after 8 years of heavy traffic, and the road is performing well. The important facts about this road stretch are that having raised the road surface almost 3/4 of a metre, it has been possible to reduce the pressure on the ground by at least half a ton per square metre. The rate of settlement has been decreasing to 1 centimetre per year, compared to the earlier almost 10 centimetres per year. Rock and landslides are not unusual problems for the road administration on the west coast of Norway. On November the 28th, 1979, a stone wall supporting road number 5 near Sogndal suddenly failed. The side slope of the slide was at nearly 45 degrees into the fjord, and further slides were expected. To allow cars to pass the site, a temporary steel frame bridge was constructed. It was not possible to construct a fill, and a new wall or a bridge had to be founded in the scree. In spring 1980, it was decided to construct a fill of plastic foam after unloading the area by removing some of the scree. This expanded polystyrene fill, with a height of more than 5 meters, is so far the highest plastic foam fill in the world, and the only one which ends in a vertical wall in open air. To take up horizontal forces, 2 12-centimetre concrete slabs were constructed, both anchored in solid rock. Special attention was paid to accurate construction of the fill due to the rather bold design. The first concrete slab was constructed over 2 meters of polystyrene. The space between the rock and the blocks was filled with granular expanded clay with a small amount of cement. The last polystyrene blocks have been placed and the reinforcement for the upper concrete slab is prepared. The concrete slab ends in an outer wall which will support the road pavement materials and the posts for the safety fence. To protect the expanded polystyrene at the vertical wall, a cover of plastic-coated steel plates was used. The reconstruction of the road cost $100,000, which is about 50% of the calculated costs of a bridge. At the same time, the traffic could pass the site undisturbed through the whole construction period. Since 1972, more than 25 fills of expanded polystyrene have been constructed, and the results have been good so far. Testing of specimens from the fills does not show any reduction in compressive strength. This means that expanded polystyrene can stand up to the traffic loads, and there is no apparent aging or decay of the material. Expanded polystyrene is not a cheap material, but alternative methods like fills of granular expanded clay, embankments on piles, or bridge construction are even more expensive. There's no doubt that the use of this method has saved the Norwegian Public Roads Administration a considerable amount in construction costs.
To learn more about our Shield Geofoam, I invite you to visit our website. Thank you for viewing our video.